Hi guys, welcome to our 30 video, and we are still talking. We will be still talking about MobX, and now we are talking about some types of reactions, or some types of listeners that we can use in MobX. Okay, um, so let's go. Let's recover. Our basic application, every time a user pushes the button, it increments to 1 plus 1. So this function is callback increment. So every time if you try to enter in the code, it will bring um, your generated code, your .g code. Okay, this is the auto-generated code we did previously. So you do not need to change here. Every time you need to change something, you will just open your controller, you will change it here, and you will use that basic command flutter publish run build runner build. Okay, you will see later that you do not need to call this command every time. Um, while so before showing it, let's first of all create our first reaction, or our first way to react accordingly every time the counter is incremented. Let me show you the computed. The computed is a way to compute something every time a variable changes. This variable must be an observable. Okay, this variable must be an observable. So counter is our counter. Let's say that every time a user pushes this button, this counter is incremented, and we calculated this times 2. So times 2, let's return an int. Okay, it will be the counter times 2. Okay, to return a counter times 2. Okay, um, uh, we have an observer widget here, and I need to show you every time a user pushes this button, we will have a counter, and the counter plus times 2. Okay, let's see here. Let's organize here. We have a column. Column makes this text, and this one appears one beside the other, below the other. And let's put here, instead of putting a text directly, let's put a row. Let's call a row here, and here every row has many children, or can have many children. Let's put our text that we had previously, but let's call it as counter. Okay, we have our counter, and we have our counter times 2. That our counter times 2. Okay, let's back to our code. Let's rebuild the screen. Okay, let's organize it. First of all, instead of the same line, since we had a row, let's put it in a different form. Let's put it, I will undo it. Let's undo it. Let's return our text, and instead of a row here, let's keep our counter here, and let's put it below our counter. However, we will need other observer, since we do not have our parent as observer. Okay, so let's return our text times 2. Okay, so instead of a row, we still have our column. So if I push the button here, it was for 1, and 1 times 2 is 2. 2 times 2 is 4. 3 times 2 is 6. 4 times 2 is 8, and so on. 5 times 2 is 10. Okay, so in a simple way, we created our counter times 2. Okay, if I need another observable, we needed to use our build runner. Okay, since we just have a computed, we do not need to run build runner again. Okay. Okay, let's keep on. Let me have some other idea. Okay, we can do other MobX. I remember now. MobX has 3 types of reactions. First of all, it's the reaction. Okay, what does reaction do? Reaction, accordingly to its documentation, receives a function, okay, and an effect. Pay attention that the function returns a value or a type, and this type is the same as the type the effect function receives as a parameter, as a input parameter. Okay, let's call this. Let's say that every time a user increments the variable, so that our counter controller, dot counter. Every time something changes, let's say in this example the counter, let's return this counter to our effect callback. Okay. We will receive our counter and we can execute something. Let's say user pushes counter times. Okay, let's push your R uppercase. Okay, upper letter R uppercase. You can make your hot restart. So everything it starts at the initial. From the starting value, I push here, user pushes 1 time, push again, user push 2 times, push again, user push 3 times. So reaction will give you a way to cope with event sourcing, and you can, for instance, update your storage, or you can send to a network, to a server, or something like that. Okay, to make things more organized, I don't like to use in this way as the inner function. I like to use as a kind of callback. So let's say counter printer. Let's call this counter printer. And our counter printer is a void function. Is a void function since it is a void function. Okay, our effect is a void function, and let's call it as counter printer. It receives our int counter. It prints as previously. Okay, so let's restart our application. It will not change. Okay, it will be the same behavior. Every time a user pushes, it just prints the number of pushes. However, I put it as a callback. It's a kind of callback. Okay, You can create many reactions as you need, however, with different behavior. Of course, let's say that when a user pushes this button, let's show a snack bar. Hit counter. You can pass here that it returns an int. It helps the compiler to know that this will be an int, that it will return int variable here. Okay, so I have in another opportunity I will explain why I will do it this way. I will put a key here. This is not from the scope of our discussion. Okay, I will do it just to create our snack bar. Global key, scaffold, state, scaffold key, scaffold key is a global key. Okay, the same type. And this key, I will put it here. This discussion about key does not include. It was not included in my discussion. I will just use it to show a different behavior that this function can do. Let's say this key, I will recover our current state, and I will show a snack bar. Okay, snack bar has a content, and this content will be a text that will just show counter. Okay, so counter will just be show. Let's date it. So take a look that this snack bar will appear. Use a push. This doesn't appear here. Why? Okay. Snack bar. I forgot to change. Let's restart. You will see the snack bar will appear below. Okay. Counter 1. Counter 2. And our console is already printing, because this callback prints the message, and this callback shows the snack bar. Okay, this snack bar. Okay, and it's important that every time you create any reaction, take a look that it returns a reaction disposer. Why? When your screen is finishes, let's say is deleted or removes from the memory, some resources can be allocated. Okay, and one of these resources is this reaction, so you cannot leave it. Okay, you cannot leave as the way it is. So you cannot leave this resource or these resources in memory. Okay, so what do I have to do? One of the callback that the state class has is the dispose callback. So we have to dispose our resources here. Pay attention. In init state, we call init state first. However, in our dispose callback, we call dispose late. Okay, at the end of all disposers. Okay, every time I create a reaction, it returns a reaction disposer. Since we can have multiple reactions, I will create here a list of reaction disposer. This is a list of disposers. This is a list. I can initialize my list here or my list here, whatever. And to dispose all reaction that we have already created previously. This will be called when your screen dies, okay? When Flutter removes this screen from memory. So since I have a list here, I will iterate for each element that is a disposer, and each element here I will call element. Okay, element is just the this for each element here you have this instance, so you can call E or D or whatever you want. Okay, no problem, but you call it is like a function. Okay, this is called as callable classes. Okay. Okay, so we are disposing our resources here. Don't forget to do that. MobX also gives you more two types of reactions. The next one is the when. What does when do? When something happens, it's true, do it as an effect. Okay, so let's say when our counter controller, let's go, when our counter controller counter is dividable by 5, let's call show snack bar again, another show snack bar too. Let's go show snack bar, another show snack bar, and let me call here void show snack bar and counter. These also have a function that does not have any input parameter. Okay, we do not have input parameter as an effect. Okay, so I cannot do this, not passing here. So I can show another snack bar with a different color. Let's say counter. This is from the counter controller. Counter. Counter. Let's put this text in different color. Text style. Colors that. Let's put yellow color here. Okay. When counter is divisible by 5, it will call the second. However, when is called just one time, okay? When is called just one time, it doesn't call every time, just once. Okay. I will initialize my variable to 1 here, because if it is 0, it will be true, and it will not call when it is 5 again. Okay, 1, 2, 2 with 2 is 4, counter 2, counter 3, which times 2 is 6, counter 3 here, counter 4 plus 2, counter 4 times 2 is 8, 5, 5, counter 5, and our counter 5 in yellow, because this second callback was called. Okay. However, it will not call anymore. When counter gets 10, it will not call anymore since it is called just once. Okay. 8, 9, and 10. So you'll see that counter in yellow color will not appear. Okay, 11, and so on. So when is one of the reaction that MobX offered to you. However, it is called this this effect is called just one time. Okay, so in our documentation you can read it as when predicate turns true, this predicate turns true. Oops. The effect is executed. The effect is this function. However, it is executed just one time. Okay, and finally, when is auto disposed. Okay, since it returns the reaction disposer, you do not need to put in our list here. Oh, I forgot to put in our list here. .add. Since it returns our disposed reaction, let's put it the disposed reaction here and here. Disposers. The right way is disposers. Okay. Disposers. We are putting our disposers into this list, and for when our page dies, it will call dispose, and these resources will be disposed. Okay, and the last reaction that MobX offers to you is the auto run. Auto run is simpler than the other reactions. Auto run runs every time, so it runs mainly in the first time. Okay, print auto run here. Let's print controller dot control inside our auto run. Okay, you will see that our auto run will show first auto run 1. Okay, you can see that any other callback was called. Okay, just the auto run. So auto run runs first, executes the specified FN. This is the FN. Whenever the dependent observables change, it returns a disposer that can be used to dispose the auto run. So we need to add this in our list too, to be disposed at the end of our application. Okay. Okay. That's it. This is our third video about the second one about MobX, and the third about our video series. And the next video we will be still talking about MobX and how to cope with asynchronous functions. Okay, bye.